appears to be slightly better. Okay, let's start. This is the cell that we're building. It's a metal plate, 2 layers of carbon at this stage. First layer is graphite mixed with the carbon, painted on, left to dry. Second, same carbon, graphite. The carbon mixes, we're trying all different shapes and sizes and methods. This particular one is from a fig tree in the garden, a wild fig tree, carbonise activated. Separator is just the basic kitchen wipe. Then we put carbon on the top there. This stage we're using battery acid, H2SO4. It's a diluted form. And then also the next one that we do use is zinc sulfate solution. This battery has been on the rest now for I think 2 hours. Let's power it up. 97 millivolts. I don't know if you can see the millivolts. 97. And current's going to be very low at this stage. 10 milliamps. Right, so it's a dead cell at this stage. Let's charge it up. Minimum max. Try and charge it for say a minute. Then we see what we get there. Use the averaging function on minimum and maximum. So the startup voltage was 700 millivolts. Average is now 1.1 volts. And your max is 2.4. This is the cell that we're testing. Bottom plate negative, bottom plate positive. We're using this stainless steel mesh for a current collector. This specific separator was doped in borax, left overnight to dry. These cells here, there's about 15 of them, all different carbon mixes. They all deliver over 1 amp. When you build the cell, a good cell gives you, in my terms now, between 600 and 800 millivolts on startup. You can discharge it. Takes about 2-3 minutes to discharge to 100 milliamps. Don't know what the cutoff point will be, but we're working on 100 and 500 at this stage milliamps. Charges back up. In 5 minutes it reaches a capacity where you discharge the cell again to a point where it can give you 500 milliamps over 3 minutes approximately, and a short circuit current of over 1 amp, some of them. This is a short charge. Let's just switch it off. 2734 is your max. 7712 is the average here. And it's off now. It's going to float at 900 millivolts. Not bad. Going to the current side. 10 amp DC. That's 1 amp. So the longer the charge, intervals, I would say 30-second charge, 10 off, 30 seconds charge, 10 off. You get amazingly high amp rating out of this. Some of these cells went to 1.8, I even reached 2 amp. And this is from carbon, graphite, activated carbon, just going to draw this thing to 500 and then we see how quickly we charge it back up again. Okay, that's close to 500. $788, $789, no, oh, it's climbing back up. $796. It's close to 800 millivolts. Let's do a current test again on it. 10 amp scale. 700, 600, well, it's pushing fine. Let's charge it. Minimum max, let's go. 2.2 on max. 2.4. Average is 1.1. About 30 seconds. See what we get out of 30 seconds here. While it's charging, I just want to show you something I've done on the collector mesh. Different test. It doesn't like to have carbon glued on it. That doesn't work. For some reason, it doesn't work. It must just be a loose contact. Why? Maybe I'm just not doing it right. That's about 30 seconds. Switch off. 990, 1 volts. Oh, dropping down. Let's do the current. 10 amp scale. 1 amp. And so we can go on, charge it, discharge, charge it, discharge. That is quite good in my field that I'm playing with. I must say, Kiev Wallcroft and Biocell, and there's a couple of chemical guys on YouTube, made quite an impact on designing these things. All have a piece of information. Somebody needs to tie them up, get all the information together. 792. RMS is probably the best at this stage. It doesn't tell you everything, you have to experiment. 800 millis. That's 800 millivolts. Let's load it again. 600. This is only a 30-second charge, if I was not right there. I'm going to leave it on charge, and I'll be back with another, say, 15 minutes or so charge.